Uh-oh, another word problem. Wing Ah averages 30 miles per gallon of gas in her car. Also, I don't know if you can hear, my wife is making a smoothie downstairs with lots of fruit. Okay, how far can she travel on 14 gallons of gas? Well, let's see what we've got here. Doesn't matter what the name of the person is. It's that the important thing is she gets 30 miles per gallon in her car per gallon. So that means she gets 30 miles. She goes 30 miles, right? She goes 30 miles for each gallon. Good idea. If you're not sure what to do, I didn't spell that. I didn't write that very neatly. Okay, it's better. She goes 30 miles on 1 gallon. Okay, so how far can she go on 14 gallons? Well, it's just a simple multiplication problem. 30 times 14. $420 miles. Now, if you're not sure about what the units should be, this is a trick for any kind of word problem, that involves units of some sort, like gallons or miles or inches or something like that, and you're doing multiplication or division. So we say, okay, 30 miles per 1 gallon, right? And that's going to be times 14 gallons. Well, what do you have left? You see that this gallons part cancels out. You've got gallons in the denominator and gallons in the numerator. They cancel out. So all you have left is miles. So the answer, 420, has to be miles. Number 28. Determine if the expression is a term. If it is a term, state its coefficient. This is just a matter of knowing the vocabulary. Right? You have to know what a term is, and you have to know what a coefficient is. And if you do, you can answer this easily, like in 3 seconds. Right? So you want to be clear on the vocabulary. Okay, so what is a term? A term is something like 65yx cubed. It's something that could have constants, variables, and powers. You have variables to the powers, and the powers will be usually in natural numbers. In our situations, they're going to be natural numbers as far as being called a term. And so the constants, all the numbers, 7, 27, 1005, those are all constants. They're just numbers. The variables are the letters, A, B, C. Variables because, they can represent, at one time they'll be representing one number, another time another number, so they vary, right? And then the powers. Each of the variables could all have powers. You could have a thing like 1007 x cubed y to the 5th power z to the 7th power, let's say. All right, because that's all one term, because all of those things are multiplied times each other. Now, in our case here, well, that's 2 terms. One term is the 10, and the other term is the negative x. Or you could say, oh, one term is the 10, one term is the x, and they're subtracted from each other, right? But there's 2 terms there, so it's not a term, so you can't state its coefficient. So the answer to this is not a term. And you have it right. Number 29. Again, same thing. Determine if the expression is a term. If it is a term, state its coefficient. Okay, so we have 60x to the 3rd power. So we have 3 things there, right? We've got, whoops, it's moving on me. We've got 60, we've got the x, and we've got the 3. So remember what I said, if you've got those constants, variables, variables to powers, and they're multiplied times each other, that's a term. So this is a term. So yes, it's a term. So right, it's a term. Okay, so now we want to know what the coefficient is. The coefficient is the number in front of the variables. So this is the coefficient. Coefficient is a constant, a number. Coefficient. It's supposed to be an E. It's hard to write with this big fat thing. Okay, this is the variable. That's the exponent. So the answer is yes, it's a term, and the coefficient is 60. Number 30. Identify the group of terms as like or unlike. Well, now we know those are all terms. 6m, 2m, and negative 5m. So are they like or unlike terms? For something to be a like term, it has to have the same variables. That means these m's, which are all the same, right? And the variables have to have the same powers. So these m's, because they're only to the first power, the 1 isn't there, but these could all have little 1's there. See, so they're all the same power. And whether they have constants or not, that's okay, because if we just had m or we had negative m, this is the constant is assumed to be 1m here, and this is assumed to be a negative 1m there. Those are the constants, see, or the coefficients. So that coefficient is negative 1, that coefficient is 1. Alright, so we've got 3 terms. Are they like? Yeah, because they have the same variable, they only have one variable, and they have the same power. So they're all like terms. So we can put yes. Like terms. Unlike terms would be like m and m to the second power, or m to the third power. It doesn't matter if they're negative or positive, you know. Those are that's not what makes them like or unlike. It's these powers. Or if they had another variable, let's say we have m, and then we have mn, and we have mx. Well, these are unlike terms. The fact if they had a coefficient, let's say they had the same coefficients. Well, I'm sorry, they're still unlike terms. We have 5 of these guys, 5 m's here. Here we have 5 mn's, and here we have 5 mx's. And all we know about them is that they're different. The only thing that's alike is the m's, but this one has, it's multiplied times the n, and this one's multiplied times x, so we cannot combine them. Don't be fooled if you have something like xy cubed and xy squared and, let's say y cubed. Those are all unlike terms. They have some of the same variables, but they're multiplied times something, or they have different powers. So these two have the same variables, but the y has a different power. This is a y to the third power, and so is this one, but this one has an x multiplied times it. See, so they're all unlike terms. Whether you have a negative or positive or a constant in front of it, that doesn't matter. That doesn't affect whether they're like terms or not. Number 31, combine like terms. So we have 8a minus 6a plus 2. So we've got to look at these. What are the like terms here? Or are there any? Yes, there are. This has only one a. Both those a's are the first power, the 1 power. So they're like terms. It doesn't matter that the coefficients are different. Okay, so we can combine those two. We cannot combine them to the 2 because that doesn't have an a. Or because you could say it has an a to the 0 power, which we're going to find out about later, which we don't even write down, right? So anyway, we can solve this. So we have 8a minus 6a plus 2. We can combine these two. 8a minus 6a is 2a. We did this already, didn't we? And then plus our 2a. or plus R2, excuse me. Cancel that. 2a plus 2. Answer. 32. 5 plus 5 times 9 minus 2m in parentheses. Okay, so we've got a solve. We have a distribution thing here. Right there. This part. And then we're going to have, after we're done distributing, we're going to have some combining like terms. Okay, so let's get started with that. Okay, we'll do the distribution first. The distribution is like multiplication. Notice we have a parenthesis, but there's nothing we can do. Nothing we can do with this parentheses. There's nothing, because they're unlike terms in there. Notice there's a 9 and then there's a 2m. So we can't do anything with that, but we can distribute the 5 over those. We'll distribute the 5 over the 9, and we're going to distribute the 5 over the negative 2m. So we'll just bring down the 5, the other 5. That's an addition. Okay, 5 times 9 is 45. So we'll just do this, 45. And 5 times a negative 2m would be a negative 10m. Positive times a negative is a negative. Alright, so now there's nothing else we can do inside that parenthesis, so we can get rid of the parentheses. And we can actually regroup that and group the 5 and the 45 if we want to. So why don't I do it? What the heck? 5 plus 45, make that a group, minus 10m. 5 plus 45 is 50, and then the minus 10m. We're done. And that's all we can do. We can't go any further because we don't know what m is. It's an unlike term. We can't combine 50, just a number, with something with a variable. Number 33. Now, number 33 is actually a little tricky. So what's going on here is not real obvious. That 8x is not distributed over the 9 and the negative 2 because there's this negative there, or a subtraction going on. If there's a sign between a number, a term, and a parentheses with terms in it, then that number is like added or subtracted or whatever the term says. If it's multiplied, if there's a multiply, well then it would be a distribution. If it was divide, of course it's not a distribution, right? So when there's a sign between them, you aren't going to multiply the 8x times the 9 and the negative 2x. However, this is a distribution problem. This could be rewritten like this: 8x minus 1 times 9 minus 2x. Because the negative in front here is a negative 1 understood. It's just like we write x, we don't usually write 1x, or we don't write x to the 1 power, or we don't write 5 to the 1 power. All those 1s are just understood. So when we see a negative sign, it means negative 1. Negative 1 times that thing, and especially in front of a parentheses. So, I mean, in the case of, for instance, okay, negative, you're thinking, oh, what the heck does that mean? Since we have a negative 5, does that mean there's a negative 1 times 5? Well, it's basically the same thing, though, right? Negative 1 times 5 is a negative 5. So I'm talking more about variables. If you have like a negative x, that really is the same thing as saying a negative 1x, right? Or a negative 1 times x. Okay, so if you have a negative in front of a, like x minus 1, outside that, then it means a negative 1 is going to be distributed. So we will distribute that negative 1 over the 9 and the negative 2x. First, we'll just rewrite our 8x, and the meaning to be in blue. Rewrite our 8x, and okay, negative 1 times 9 is a negative 9. Negative 1 times a negative 2x, positive 2x. Okay, so now I'm going to combine like terms. And you notice I'm going to use our commutative property. Our commutative property, well, there's another thing I need to tell you about before I start talking about the commutative property here. If we see all these numbers as added together, because 8x minus 9 plus 2x, that minus 9, we always change when we subtract in algebra, we always change our sign or our operation to a plus, right? And then we change the sign or make the number that's being subtracted the opposite, which is the same thing it was before. 8x minus 9 plus 2x. You see, it's still a negative 9. So we could see each of these terms as being added together. They're all added together. So when you see a list of terms, let's say you saw this, negative 8 plus 8 minus 3x plus 7x minus x minus 9. Okay, so let's say we saw that. We could think of it as in terms of all those terms. Those are all separate terms with a sign in on them. So that's a negative 8, that's a positive 8, this is a negative 3x, this is a positive 7x, this is a negative x, and this is a negative 9. And those are all added together. Alright? So, of course, when you add a negative and a positive, you subtract them and keep the sign of the larger number. That being said, we've got 8x minus 9 plus 2x. And since they're all added together, the signed numbers all added together, we can commute them. You can commute addition and you can commute multiplication. So we're calling these, so we can put this 8x plus 2x minus 9. You can put it like that. And we can add our 8x to the 2x. Or you could just add them together like this, you see them in your head. So we've got 10x minus 9. 34. Translate the phrase into a mathematical expression and then simplify. See, that's giving us two instructions. Well, actually three. It says use x as a variable. So you got to use x as a variable. If you use n, you're not going to, if I was correcting it, I wouldn't give it to you wrong if you used n. Because sometimes we get flustered, right? Because you'd have it basically right. But anyway, it says to use x as a variable. But there's two things you're supposed to do. You're supposed to translate the phrase, and then you're supposed to simplify it. So if you only did half of that, you'd probably leave out the easy part and get only half credit for the problem. That's why I'm emphasizing this. Okay, so we got to translate this. 6 times a number added to the sum of the same number and 6. You might want to read it a few times. Always with word problems, read them several times until you get a grip on it. Okay, so we'll stick numbers underneath when we can, when it makes sense. 6 times a number, so to use x, added to the sum. Whenever you see sum, difference, quotient, added to the quotient, added to the difference, added to the product, you see those type things, you're going to put in a parentheses for the stuff it's talking about in the sum, or the quotient, or the difference, or the product. Okay, so the sum of the same number would be x again, and 6. Okay, so let's do that again. I'm going to put it right under the numbers. Alright, so 6 times a number added to the sum. Okay, so parentheses, sum of the same number, sum plus, see, 6. So we would write it like this: 6x, because 6 times a number 6 times x is 6x, plus the sum of x plus 6. Okay, so now simplify. So we can, of course, associate the 6x plus the x, right? 6x plus x plus 6. So that gives us 7x plus 6. Here's an easy one. Provide an appropriate response. Number 35. In the term 12x squared y, the number 12 is called the what of the term? Well, as we've learned already, it's called the coefficient. The number multiplied by the variables, multiplying times the variables that are multiplied times each other or whatever is in the term, that's the coefficient. So, congratulations. That's the last problem. You can run back, go over the ones that are difficult for you. So, that's it. You can go back and forth and keep watching the same one over until you get it. And I hope you do well.